Hello everyone. Today we are going to see the lecture on process, threads and CPU scheduling. Before going to the depth, we can see what is a process. A process is a program that is currently being executed by the computer. It includes the program code, current activity and all the resources it needs. In simple terms, we will tell the process as an active running instance of a program. There are a few differences between the process and the program. A program is a set of instructions written that is used to perform the specific task stored in a file. It is a passive entity. Process is a program that is actively being executed by the operating system. It is an active entity. A program is just a code on the disk, but the process is the program in action. The parts of the process. The program code is also called as the text section. The current activity including the program counter, processor register, then stack containing the temporary data, then data section that contains all the global variables, heap contains the main memory dynamically allocated during runtime, and program is a passive entity, process is an active entity. Program becomes process when executable file is loaded into memory. One program can be several processes. Consider a multiple user executing the same program. What it does? It spends more time waiting for input-output operations, reading from disk or wait for user input that actually using the CPU. A program that frequently reads and writes files or waits for user input. Characteristics: it spends more time waiting for data than doing the actual processing. The CPU bound processes. What it does: uses the CPU for intensive calculations, computations, and does not wait much for IO operation. Example is a program that performs heavy mathematical calculation or complex data processing. Let's move on to the process state. A process executes, it changes state. There are a few states in a process. New, the process is being created. Running, instructions are being executed. Waiting state, the process is waiting for some event to occur. Ready state, the process is waiting to be assigned to a processor. Terminator, the process has finished its execution. So this is the diagram that represents the process states. The first state is the new state. The new state is a process is just created. In new state, the process is just created and waiting to be assigned to CPU. Then the next is ready to running state. Ready to running state. So that is scheduler dispatch. Ready to running state, that is scheduler dispatch. This is selected by the scheduler and is now executing on the CPU. Then running to waiting state. Running to waiting state. So the running to waiting state, during running to waiting state, IO input output operations or even wait will happen. The process need to wait for an IO operation to complete. Here the process needs to wait for the IO operations to be completed. Then wait into ready state. Wait into ready state. Once the IO event is completed, it moves from waiting to ready state. Then running to ready state. Running to ready state. If there is any interrupt, it moves from running to ready state. That is, when it takes more time to execute, the CPU is taken away from the processor. So at that time, an interrupt will occur and the process will move from running to ready state. Then the final one is the exit state. Once all the process has completed its task, it moves to the termination state. Thank you.